All right, here we go. To find the rest of these answers, remember we have lengths of the sides, 16, 12, and angle 1 is 60. So we're going to find the following, LX. So LX is here. We found that the whole thing yesterday was 20. So in a rectangle situation, the diagonal is cut directly in half. So D, LX is 10. Angle LON. Angle LON. This is a rectangle. So this should be a right angle. So angle LON is 90 degrees. Angle 2. Well, if one part of this is 60 and this is a right angle, the other part is 30, which is 90 degrees. Or excuse me, 30 degrees. 30 degrees for F. Next one, OX. If we already know that the lengths of the diagonals of a rectangle are congruent, then we know if this one's 20, this one is 20, so half of it is 10. So OX for G is 10. Angle 3, if this one, let's see here, how can we work this? This does not have to be right angles. All right, in a rhombus situation, this would be right angles here, so we would have a 30, 60, 90 situation. However, that's not the case. So, how do these two angles compare? So, they don't bisect each other either. But angle 3 is 30 degrees. And angle 4 is 60 degrees. All right. So that would be number 1. Questions on that? All right, rhombus number 2. So, definition of a rhombus states that the diagonals bisect the angles. They also intersect at a right angle. So you got 4 right angles in the middle. So let's see, WXYZ is a rhombus. We're going to label this WX is 4. This angle 60. Find the following, WY. All the sides of a rhombus are congruent. So if WX is 4, WY is the diagonal coming across. Now these two diagonals are not congruent, but I do know that these are all 4s going across. So if we use Pythagorean theorem here, well, we can't, because we take that back. We can't use Pythagorean theorem here and here, but the right angle is in the middle. XY. Oh, we're looking for XY. Oh, we know what XY is. 4. CWX. If this one's 60, the consecutive angle is 120. Because they add up to 180 in a parallelogram situation. If this angle is 120, how much is each one of these? Well, remember, in a rhombus situation, the diagonals bisect this. So these are both 60s. So therefore, angle 1 and angle 2 are both 60 degrees. Angle 3 and 4, if both of those add up to 60, and this is cut in half, so angles 3 and 4 here would be half of 60, which is 30 degrees. Okay, now, since we know this is a 30, 60, 90 situation, this is not going to be, well, at this point in time, we have the length of the hypotenuse, which is 4. So the angle WO is actually 2. And there's a reason for that. Just write that down. G is 2. OX would be 2 square root of 3. And WY is actually 4. Because if this one's 2, this one's 2. And that adds up to 4. So that's how you get a couple of those. There's something called a 30, 60, 90 triplet. And the ratios is 1, square root of 3, 2. All right. Last one's a square. Everything's perfect in a square. So EF is 10. Find the following. FG, 10. Angle EFG, 90 degrees. That one right there. EG.
20. Wait.
EG. Now, since that's a 90 degree, this actually is 10 square root of 2. Some of you may have used Pythagorean theorem on that. EI, EIO, it'd be 5 square root of 2 is half of 10 square root of 2. You wouldn't have known that. IF,
Same thing.
yep. Same thing, 5 square root of 2. EIF, 90 degrees, because this is a rhombus as well as a rectangle, so these intersect at a right angle. Angle 1, well, remember, if this is a rhombus, these are perfect angles. And if the whole thing's 90, then half of it is 45 degrees. Angle 1 is 45 degrees. Angle 3 is 45 degrees. And HF,
Wait.
10 square root of 2. So a couple of those is pretty, anytime we got the square roots. Because in a 45, 45, 90 triangle, it's 1, 1 square root of 2 for the ratios. But you're supposed to learn that in a couple more units down the road. We're not going to get to that for this class. All right. On the back of this page, didn't expect you to do it. Some of you got to it, and that's fine. Because I started completing this, and it got a little more difficult. So, this is a rhombus. PB is 12. AB is 15. Angle ABD is 24 degrees. (24 degrees). Find each measure. A to P. Well, this is a right angle. This one's actually 9. The reason why, this is x squared plus 12 squared equals 15 squared. And if you use Pythagorean theorem there, you can find that side, and it will be 9. CP. C to P. If this one's 9, this one's 9. Next one, BDA. If this one's 24, this one's 24, so this one's 24, because the angles in a rhombus are bisected by diagonals. And ACB, the angle ACB, well, this is 48. This is 180 minus 48. And you get 132, and then half of 132 is 66 degrees. So that's what this angle measure is, 66 degrees. Because both of these add up to 180. So we just use some 180 stuff, subtraction. All right, then number 2. WXYZ is a square. WT is 3. Find each measure. ZX. Well, if this one's 3, this one's 3, so the whole thing is 6, so the other side is 6 as well. XY. If this is 3, this one's 3, this is 3 square root of 2 just because of our ratios. This is why I didn't require you to do the back. That's why I'm going over it now. 3 square root of 2. Measure of angle WTZ, 90 degrees. Measure of angle WYX, it's half of 90, 45 degrees. All right, So now, I'm going to give you these worksheets. We're going to go over a couple of these definitions. Yesterday. Yeah.
We supposed to have 2 sheets or one?
Just one. All right, working with trapezoids a minute. A trapezoid. Definition: a trapezoid is a quadrilateral of one pair of parallel sides. So obviously the bases here, these are parallel to each other. So you got these transversal lines cutting these parallel lines. That's the whole point of a. So you got the alternate interior angles, alternate exterior, same side interior, and corresponding. Now, an isosceles trapezoid is a trapezoid where the legs, you see it says leg, the legs are equal. So that's the definition here. An isosceles trapezoid is a trapezoid with non-parallel sides congruent. Basically, legs are congruent. The non-parallel sides are called the legs. And so therefore, there's some extra special stuff in an isosceles. First of all, an isosceles trapezoid, each pair of base angles are congruent. Each pair of base angles are congruent. So that means that this one is congruent to that one. And then this one is congruent to this base angle. All right, next one. If a trapezoid has one pair of congruent base angles, then it's isosceles, so it works backwards. A trapezoid is isosceles if and only if its diagonals are congruent. So also, if we draw the diagonals from one corner to the opposite corner, those two are equal as well. That makes sense. So, therefore, you have the theorems that I just went over on this page. So you don't have really any writing here. This is an isosceles trapezoid, but it's just turned sideways. The legs are congruent. This is isosceles trapezoid. QS is congruent to RT. All right, so on the back, we need to follow the rules on the front of this page and work on this. Shouldn't take you too long. Got to find angle S, angle M, and then the angles 1, 2, 3, and 4 for this particular one. Remember, this is a transversal line. So 50 is here. I probably think 50 might be right there. And remember, the base angles are congruent in an isosceles trapezoid. So if you know if this one's 50, you can find the measure of angle 2. Same idea for this trapezoid. And then either you're going to set these equal to each other. It's probably what I would do for 5 and 6. So let's work on this a few minutes up until lunch.